that's been orchestrated by a container orchestrator that is meant to run in a multi-node environment. And let's double click on why I say that. An application is never one single container, right? So take an example of Cassandra. It's usually deployed as a set of containers. A Cassandra cluster could have 3, 10, 15 Cassandra containers that are all orchestrated and deployed across maybe 15 different machines, potentially even in different availability zones. So to try and take a volume and somehow magically orchestrate this into a distributed application environment, you end up with a lot of problems that ends up having the operators or the architects for the platforms, as architects that are building the PaaS, have to go in and add significant glue around and making sure how to orchestrate these into the applications. And then you run into problems exactly like Venkat was talking about, which are, now I want to take a snapshot, or I want to have a common encryption scheme across this particular application. Maybe the key used for that application is different for a completely different business unit that's deploying a different application.
That's right.
How do I provide these different keys in a cloud-neutral way and don't burden my end users with making this a science project? That's really what the value of the Portworx layer is. At the core, Portworx is a software-defined storage solution. Venkat talked a little bit about CSI. CSI is going to be coming out in a couple of weeks. As soon as it's out, Portworx will have one of the first implementations of CSI out there. In fact, in a couple of weeks, we'll be announcing our release for CSI. But all of these are meant to make the integration with the container orchestrator much more easier, and to make the lives of, like Venkat and Balajee, in managing their platform as a service really hands-off, and everything is just happening on its own. They have end users, their own internal customers that they have to cater to, and in their ideal world, they're going to put together a platform where their end users can go in and programmatically say, I'm going to run my 5-node Cassandra cluster, give me a few terabytes of storage, and boom, it happens. They don't have to go in and provision it beforehand. These are the question you asked is, what are problems people running into? That's what they're running into. When somebody has to run, for example, a 5-node Cassandra cluster, somebody has to go in and figure out which machines are this going to run on, how do I get storage to it, and then invariably, those applications are then permanently pinned to those machines because they have consumed resources from it. And when a machine dies, somebody has to go in and figure out how to take it off of that, move it somewhere else, and you're really not leveraging any of the cloud native benefits that these orchestrators want to give.
Right. So how do you manage that underlying architecture with these storage considerations in mind? So, so if a node goes down, you can just take care of it.
Sure. So one of the things that we started off was to build a cloud agnostic platform, so that we don't want to overburden, just like what Gou just said, we don't want to pass on the onerous task of managing infrastructure onto our end customers as well. So we've abstracted out, and there's an abstraction that we go on with every layer of Predix itself. So when we go deploy Predix on a brand new point of presence, be it Amazon or Azure, we have automation that abstracts out the underlying infrastructure first. And then we go down and lay a common interface of our platform as a service layer, which is Cloud Foundry and Mesos. At the end of the day, our end users interact with one or both, and they consume Predix no matter where Predix is deployed. Within that, we provide constructs. For example, the talk that we gave today was our open service broker implementation, which is essentially a broker marriage between Cloud Foundry and Mesos, where people living in the Cloud Foundry land can consume a backend service running on Portworx using our broker interface. That's how we are solving that problem.
That's right. So just to add to that, we are planning to open source the open service broker implementation at some point, so pretty soon. So, can you sort of go back and sort of touch the question again?
Yeah, I just was looking, understanding your own technical architecture and how you think about storage there. Like, what maybe you can tell us a little bit more about your own technical architecture. Are you running? Is your what programming language are you using for the underlying architecture, and what is that runtime, and and how are you thinking about using, how you have to think about storage differently?
Okay, perfect. So in general, we So Predix is an IoT platform that actually offers folks to be able to run any language,
Right.
applications on any language pretty much. So it's a microservice-based architecture. But to focus on the storage portion of this conversation, so prior to Portworx, our involvement or this thing with Portworx, so we've always run all of our persistent store using an infrastructure that's built on top of Bosch or Chef or Terraform.
Okay.
So these are, I mean, because Cloud Foundry doesn't natively support running these sort of pin persistent clusters, so we got to basically set this up outside of Cloud Foundry, attach it to Cloud Foundry via our service broker. With this newer model, so we're able to essentially sort of use the sort of the two-state scheduler from Mesos itself to sort of decentralize the scheduler portion, and also use a solution like Portworx so we can essentially go and do dynamic persistent volume provisioning. Yeah.
Excellent.
And maybe you could also mention your use of frameworks, which.
Oh yeah, absolutely. So when we started looking at Portworx and Mesos, I think one of the very important thing for us is the availability of at least some persistent stores or frameworks on Mesos to actually use that as a starting point. So we looked at Elasticsearch, we looked at the Cassandra framework, and we looked at Redis and other persistent framework, and we started working with both Mesosphere and Portworx to sort of make sure that these frameworks actually have a native support for a dynamic persistent volume. So it started as a beta, and then we've essentially made some good progress right now. So now we are at a position where we can actually go and spin these clusters. And some of the testing that we have actually done are like pretty interesting in terms of like mission failovers and whatnot. So if a particular container actually goes down and comes back up somewhere else, we are now able to have the ability to be able to sort of take that particular volume that's there on that old sort of failed container and attach it back to a new container. So your customers, for most part, of course there are edge cases in these things, for most part are still able to go back and look at these system as if there was like no change on the infrastructure we had.
Gou, perhaps you could take us through how you guys built out your own technical architecture to be able to provide the service that you do. Can you tell us about that underlying architecture itself?
Sure, absolutely. At the core is a distributed block software-defined storage solution, right? So
Is it built in Go?
No, it's built in C,
Okay.
C++ actually. Performance is very key for this environment. One of the architectural tenets is look at how modern applications are built today. I mean, just to kind of walk you through it, if you were to roll back 10 or 15 years ago, it wasn't easy to get, if you had to get 10 or 15, 20 terabytes of storage, it would almost always come off of a network. It would come off either off of a SAN or a NAS. But over the past 10, 15 years, Intel's ecosystem has made so many advances that now it's easy to go buy a server and get 10, 15 terabytes of local capacity storage, right? And you want to be able to take advantage of this. In parallel, modern applications are built like Cassandra or Mongo or HDFS, and these inherently like to scale out and handle the scale out and the aggregation themselves. What I mean is, if you take a look at Cassandra, you would want to give it the illusion of direct attached storage or this notion of hyperconvergence. Keep these two things in mind because these are important for me to describe how Portworx built out its software architecture. Our software architecture fundamentally enables people to run their applications hyperconverged. So it's more conducive for applications like Cassandra because you get that low latency access. Your applications are running close to where their storage lives. Secondly, the other thing that Portworx does is it natively integrates with the schedulers. So it knows how to talk to either DCO, Mesosphere, or Kubernetes, and work with the schedulers such that these applications are orchestrated in a sensible way. To give you an example of that, if you're going to deploy Cassandra cluster, you don't want all the nodes in the same ring to end up in the same availability zone or failure domain. Or, for example, if it's on-prem, on the same rack. It's Portworx's architecture that lets you figure out how to distribute these applications sensibly Also, the other thing is, typically, people are aiming for close to 80+% server utilization. What that means is we have to allow for different types of applications to co-reside on the same hardware without having IOs conflict between them. So what Portworx does to mitigate this is we don't actually directly take the drive or disk or a physical LUN and give it to an application like other products would do. We provide a virtual software storage volume, which is what the application actually talks to. This virtual volume then can implement all of the I/O leveling and making sure that people aren't stepping on each other's toes. Container granular encryption or container granular snapshots are all implemented at that level.
Interesting. So where do you guys see your platform? How do you see your platform maturing with storage technologies, and what do you want to try to accomplish over the next 6 months or 12 months?
To answer that better, so the biggest challenge that we as platform operators and platform architects, what we feel is when we provide a platform for our end users, we want to make sure that platform is highly available. That's our biggest challenge, right? That's where Portworx comes in. The way Mesos gives you a unified fabric of compute, Portworx provides a unified fabric of storage, so that we can then have end users not worry about having how to consume an HA application. That's what Portworx gives us. And going down 6 months or a year down the road, we want to be able to have this running across the world in all other point of presence as well, other cloud providers, and then on-prem definitely.
So Gou, so perhaps you could tell us about the next 6 months and talk about that issue of high availability, because I know you brought this up in a story that you wrote for the new stack about some of the drawbacks with Amazon EBS.
Yeah, I think the key thing to keep in mind here as people. Stateful services with containers over the past 12 months has become such a hot topic because people are now pushing these things into production at a faster than anticipated rate. The point that I wanted to make in that article is day one deployment is always easy, right? I mean, it's easy to put something together and say, here, it's working. As time goes on, your systems age. You have various things that come into practice that we've learned over the past 12 months in working with GE and others. With what happens in production, drives fail, end users are sloppy. They'll start an application and leave things up and running, and over time space gets consumed. So it's the day two operations that are difficult. And it's very important for us to emphasize as an ecosystem over the next 6 months where people can go wrong in the day two operations. And so the type of problems that we've seen people encounter are things like network partitions or drive failures, and then having applications all of a sudden have a storm for wanting to be scheduled on a set of other servers, and now all of a sudden you're draining the storage resources from that server. So it's all of these things that you asked a question about where do I see things going in the next 6 months. It's these type of operational practices that we want to jointly, let the ecosystem and the community know of what to keep in mind, regardless of the solution that they use. Obviously, in Portworx's case, we're very cognizant of these problems. We've been learning from our own end customers in how to make the product more resilient to these type of things. And I've got to tell you, this ecosystem is so fantastic because when there's a real problem, customers are willing to work with you, and they'll show you the type of problems they have. So it's important to learn from that, put it into the product. And my key answer to your question is anticipating what problems can happen, and then making the product be aware of it and react to it, and allow for admins to go in and fix any kind of physical infrastructure, but not have to encounter the burden of application level uptime and high availability. It's those things that are important.
Excellent. Any last thoughts?
I think no. You sort of nailed it in the head. That I think as we move forward, I think we're going to essentially start looking at running multiple types of workloads, and people probably an application that's very, very high I/O intensive versus something that's more throughput intensive. An ability to be able to run all of this in this one cluster harmoniously is going to be the key thing for us. Yeah, and then making sure this is highly available, it's durable enough that we can actually rely for very business critical applications. Yeah,
and I think GE showcasing what they've built over here, that's key, right? Because we work with a lot of customers, and it's the same thing that they're trying to do, which is key goal here that cloud architects like Venkat and Balajee are trying to do is, how do I get my end users that same agility that the Twitters, the Facebooks, and the Googles of the world get? How do I build a programmable self-service layer that's cloud agnostic? They can go from AWS to Microsoft to on-prem seamlessly and not impact their end users.
Right.
So that and the more they talk about what they've done there, that also is important.
Great. Well, thank you all for taking some time to talk with us today here at MesosCon, and I look forward to keeping in touch about all your progress.
Cool. Thank you.
Thank you.
Thank you.
Thanks.
Okay, just stand there and chat.
Yeah, we just got to chat for a few minutes because waiting for the stream to go down. That was good.
But we're off.